last week we learned about the different types of factoring. We talked about the common factor or the greatest common factor. We talked about the difference of squares, and we talked about the sum and product. Yeah. Well, as we know that it's not, sometimes there's a combination of factoring, okay? And you always, the first thing that you always have to look at, as I said before, is the common factor, okay? So always you're going to ask yourself, do I have a common factor? If you do, you're going to have to factor it out. Then you're going to look at the other two options, okay? So common factor first, then you're going to see if you can do difference of squares or if you can do sum and product. There's no way that you're going to do both difference of squares and sum and product at the same time, okay? It's either or, but you can do common factoring first, okay? So, for example, 3x squared plus 21x plus 36. The first question I'm going to ask yourself, the question is asking me to factor, is do I have a greatest common factor? What's your greatest common factor for this? 3, right? So I can divide each term by 3, so my greatest common factor is 3. I divide each term by 3, that gives me x squared plus 7x plus 12. Okay, so I divided each of the terms by 3. Now I did my greatest common factor. Now I have to look at what my leftover is. So if I'm looking at my leftover, since it's a trinomial, which is 3 terms, what would be my option? Difference of squares or sum and product?
Sum and product.
Sum and product. Anytime you have 3 terms, a trinomial, it's going to have to be sum and product that you're looking at. Okay? So sum and product is for trinomial. Right? So 3 terms. And the difference of squares would only work with a binomial, but remember they have to be squared term and a minus between them. Okay? Okay, so if I'm looking at my trinomial to do sum and product, what am I looking for? 2 numbers that?
When you multiply, it has to have 12.
Multiply to 12?
And add 7.
Add to 7. So what multiplies to 12 and add to 7?
4.
3 and 4, right? So if you're looking at 3 and 4, they add to 7, they multiply to 12. So I just do 3x plus 3x plus 7, close bracket, and it's fully factored. Yeah. Yes, so this is a trinomial, right? X squared plus 7x plus 12. 3 terms, right? So 1, 2, 3 terms, okay? A binomial, you have only 2 terms, so we'll see an example after, okay? So you're always looking at the common factor first. What would be your greatest common factor, if you have any? Sometimes you don't have any greatest common factor, then you can skip that part. Okay? So if I'm looking at 2x squared minus 50, what would be my greatest common factor? 2. So if I factor out at 2, then I have x squared minus 25. Now if you look inside the bracket, there's only 2 terms there. Okay? So that's a binomial. Okay? Now, are these 2 terms squared terms?
Yeah.
Yes. Is there a minus between them?
Yes.
So I can use difference of squares, correct? So my difference of squares says, open 2 brackets, one has a minus, the other one has a plus, and then you do the square root of the first, so that square root of x squared is x, square root of 25 is 5, and that would be my difference of squares. Do you remember that? What if I had this? What if I had negative 2x minus x squared minus or plus 50? How would that, what do I have to do here?
Minus negative 2.
Negative 2, right? Remember that if your a is a right? So that's going to be negative 2x squared is 25. Okay? So you have to factor that negative 2 out. Right? Even if you have, let's say, negative x squared plus 1, what would be your greatest common factor here? Negative 1, right? So you'll have x squared minus 1 left. Then you can see these are difference of squares. Okay? So you always have to look at, if the a value is negative, you're going to have to factor out that negative. What will be your greatest common factor for the next? 4. And then what do I have left?
X squared
X squared minus 2x,
minus 2x
50.
minus 50.
Looking for two numbers? What do they multiply to?
5 and 3.
So multiply to negative 15 and add to negative 2, right? Multiply to negative 15, I don't have that many options. Negative 15 and 1 and 5 and negative 5 and 3. So I think negative 5 and 3 is my answer because that adds to negative 2. Okay. If you want to check your work and make sure that what you've got is correct, you can always multiply on the side. Don't do it on the test because then I'm going to ask you, where do you stop here? Right? So to check that the answer that you got, if you expand, you get back to what you started with. Are we okay with this? So always ask yourself, do I have a greatest common factor? Where did you get the question that you showed me in the morning from? Okay. Well, let's do it.
Do you remember?
Yep. Factor. Okay, take 2 out. Is this my greatest common factor? Is 2 my greatest common factor? So if I take 2 out, then I have 100. Is this all what I can take out?
No, 8.
Because you're always looking for your greatest common factor.
But here it's okay. Like
It's okay, but it won't be greatest. It won't be factored completely. It won't be complete factor. If I take another 4 out,
Yeah, I guess.
or 4 from,
No, another four. So it would be 8. It's like
can I take a 4 out of this? Can I divide 144 by 4 and 100 by 4?
Isn't it 200?
Yes, but can I from this one,
yes.
can I factor out a 4?
Yes.
Yeah, but
So
still you're
200
gonna have
is
It's
50,
25.
and 144 is 36.
So 25 you mean, from this. Yeah, so I can factor out, if you look at the beginning,
8.
I can factor out an 8. 8 would be my greatest common factor,
yeah.
okay? Letters, they're not the same.
I keep it 100 because it's easier to.
Yes, but it won't be factored completely. You're right, but it won't be factored completely, right? So you have to do extra steps at the end.
Oh, yeah.
Okay.
8.
One step more.
So my greatest common factor is 8. So that's 25x4 minus 36y6. Okay. Looking at this, is this a binomial or a trinomial?
I know.
2 terms or 3?
Still.
2 terms, right? 1, 2. Yes? Is there a minus between them? Are my terms squared terms?
Yes.
Okay, how do I know that they're square terms?
At the square root?
Yeah, because 25 is perfect square.
Okay, 25 is a perfect square, yeah?
And exponent 4 is even.
Yeah.
Exponent
So remember that the letter should have an even exponent be a perfect square. You remember that? And then you remember that the numbers, we said 1, 4, what was it? 1, 4, 9, 16, 25, 36, 49, these perfect square numbers. You remember them? 25 and 36 are perfect square numbers. So that tells me that these two terms are perfect square terms. Are we okay with that? So, then I can do difference of squares. Minus, plus. What do I do for the first term? I have to square root it, right? So let's square root 25x4. What's the square root of 25? 5. What's the square root of x to the power of 4? X to the power of 2. Remember that anytime I square root a letter, I divide the exponent by 2. Right? So square root of x4 is the same thing as x4 divided by 2. Okay? You always divide by 2. So I put that in the first spot. How about the square root of 36y6?
6y squared.
6y
Cube.
cubed. Right? Because if I do 36y6, square root of 36 is 6. Square root of y to the power of 6, if I divide that by 2, that gives me cube. And that is now factored completely. Okay? All right. So, the surface area of a cylinder is given by the formula 2 pi r squared plus 2 pi r h. They're asking you to factor the surface area. What do you have to do to factor it?
To replace the radius. 3.
No,
Out.
I just need to factor. I haven't gone to B.
2 pi r out.
2 pi r?
Yeah.
Are we okay with 2 pi r, everyone?
Mm-hmm.
There is a 2 for each one term. There is a pi for each term. And there is radius in each term, yes? So 2 pi r is my greatest common factor. If I divide each term by 2 pi r, what do I have left? For the first term, what do I have left?
R.
Just r, because 2 and 2 cancel, pi and pi cancel. R squared over r is just r. How about my second term? 2
H.
pi r, so I'm left with h. So this is the most factor. I can't factor anymore, correct? All right. A cylinder has a radius of 3 centimeter and a height of 10 centimeter. Use both the original expression and the factor expression to find the surface area of the cylinder to the nearest square meter. So they want you to use the original formula and the factored formula, and they want you to plug in 3 for the radius and 10 for the height and solve. Okay? So 2 pi, my radius is 3 squared plus 2 pi times 3 times 10. Are we okay with this? So I'm replacing the radius with 3, the height with 10. So if I'm going to do this without a calculator, what would I have? I have to do BEDMAS, right? So I have to do my exponent first for the first term. So it's going to be 2 pi times 9 plus this one I can, I guess, multiply the numbers. 2 times 3 times 10. So that's 60 pi. Can I simplify my first term? 18 pi plus 60 pi. So that's 78 pi. I can leave it as 78 pi. I don't have to. If you want to use a calculator and see what 78 times pi is, you can do that, but I can leave it like this. My unit for this is going to be centimeters squared, right? Surface area is a squared meter. You can, but I'm gonna leave it like this. I don't have a calculator, I'm gonna leave it like this, okay? For the second one, I have 2 pi times 3, and then 3 plus 10. So I have 6 pi, because 2 times 3, that's 6. And then times 13, right? I added the 3 plus the 10. 13 times 6, 78 pi. So there, did you find this, that the factored form is easier to just solve, right? It is, right? There's no square, there is no like 2 terms that I have to separately do and then add them together, so it's easier, right? The question is, why would the factored form of the formula be more useful than the original form? It's just easier, right? It's easier to evaluate, okay? I'm not gonna write anything for this. There's not much to write, it's just your opinion. Why do you think it is? I say it's easier, less operations, okay? I don't have to do too many operations.